Hello guys, in this video I will show you how to etch and make a PCB board for pick and place pen. So first you print out your pattern developed in KiCad and you carefully measure it and write down the real values that your printer outputs, because the printer will change the dimensions on board just for small values, and then you apply these corrections in KiCad when you print it out. After that I usually print out the margins of the board and a top layer PCB, and then I put all components, the bigger components and with the like funny footprints, I just like place them on top of it just to check is everything okay, and then if I'm satisfied with it I just cut out the board. These dimensions usually they are specific to a printer, but I do this every time before I print because they are sometimes changing. Now I'm placing this cutout on top of the board. I mean casing that I'm going to use, and if everything is okay, now you can mark the sides of a board and leave a few millimeters on each side, just in case. So I have this double-sided PCB board, and this is A4 size, so I need to cut it first to size and print out the bottom copper on it. So here I'm testing the board, and if everything's okay, you will need a sharp knife for this, because I will not be cutting with the saw, I will be just scoring the board. So just score the board with your knife or anything that you have on you. It needs to be sharp, I repeat. And usually I score one side more than the other, then I mark here the other side, and then I just score it again. And when you're finished scoring, 10 or 15 times is enough. You just press it hard, and if it will snap. You can hear the sound like it's going to snap, like small crackling. And I will repeat the process for the other cut. Just score one side several times and then snap it. Okay, now we need to deburr and sand the sides because they will be rough, and then you need to sand the copper. It doesn't have to be too thoroughly, but you just need to clean it. After that I usually put some acetone on it and rub the surface clean. One side of this board I will protect, so I will etch only one side. So I go back to KiCad and I switch on only bottom copper, and then I switch all technical layers off. You can see the X scale and Y scale just on the bottom, and then I usually preview it. So this is on top of my page, it's okay. And for bottom of the page you need to switch off this mirroring. So I print it out, and this sometimes happens in KiCad. I don't know why on my printer. So you see all the wires are wrong. So I go around it by printing it in PDF and then just printing it again in a printer. So this is toner transfer paper glued to standard A4 paper, and I just print it out as usual. And if everything is okay, you can cut it to size, but you must be careful that this sides are the side that has the toner is clean and there's no damages on it. I had some damages previously. You will see at the end when I finished with everything. Now I put it with the toner side facing my PCB board, I mean copper side. Well, I will check it here again just to make sure, and then I protect with a paper towel and just press it for like, I think 2 or 2.5 minutes is enough for this toner transfer paper. I put my wife's iron on maximum, and when you're finished, well, this is very hot, you need to be careful. So I just quickly transfer it to water just for, you know, a few seconds, and when it cools down you can carefully peel off the top layer. And I mean carefully because you can peel off some of the, you know, some of the toner if you're too fast. Okay, the board is not perfect, so I needed here to just repair it with a Sharpie. And when you do this, you must be careful not to repair any parts that are like meant to be there, like these drill marks over here, these three. So if everything's okay and your board is, you know, if your board is printed, you can check it like closely. Then I usually heat up my ferric chloride. I have this solution, you can see this from August 2012, so I use more or less the same solution. I just keep adding water and more ferric chloride. So this is ferric chloride. I will just put a small amount here, you know, this stuff that's been, usually it's solid, it's not this liquid. Okay, so I have my ferric chloride warmed up and I can dip my board into it, and this will last for a while because this solution was not strong. Let's say for about after an hour and a half the board is completely etched, so you can put it into water, and after that you can check are there any errors. So you can see the black spots where I applied the Sharpie, and they're fine. So I will continue doing this board. I will sand off this top layer and then again check my printout. So I printed the top layer mirrored on a photo transfer paper, and then here I put 1mm or 0.5 mm drill. This will be just for registration marks. As you can see, I protected the copper with a tape, and then I just carefully drilled out this registration marks on my board. And the reason why I did this, you will see in a second. I did the same thing on my silkscreen layer. This is plain photo paper. I think it's inkjet photo paper. I'm not sure, but you can do this with regular paper or glossy newspaper or stuff like that. And well, this is not complicated. So sorry for focusing here, my camera just gave up on me here. So I just put 2 drill bits, the same one that I used to drill this down. I put down the photo paper with the silk screen on it, and I just iron it for like 10 or 15 seconds until the toner is glued to a PCB. Okay, then again I protect everything with a paper towel and iron it for like 2 minutes. The thing is, with this 2 minutes is maybe more than enough. I think minute will be okay. This is also hot, because you will see in a moment, the more you iron, the more plastic you will transfer to your PCB. So do not exaggerate, just 2 minutes is enough. And you need to do this carefully, extremely carefully, and dip your board, for like half an hour if you cannot peel it immediately. This one was in water like for a few minutes. Well, it looks perfectly, but when it dries out you can see this white plastic marks, but you can clean this with isopropyl alcohol pretty easily, and do not use acetone because you'll wipe everything off. So I briefly checked the registration, so everything is lined up perfectly, more or less. So the next thing I need to do, and this was my error, I needed to do this first after etching, because I use acetone to remove toner, and acetone is basically destroying the silk screen on the bottom side, top side. So I'm preparing the board here for the for the solder resist. So the process is the same, just sand it off with a bit of paper and clean it off with acetone. And I use overhead transparencies for solder resist layer. This is regular one you can buy in any store. So I print it twice, because only one layer, in my experience, is not enough. Sometimes the UV light just protrudes through one layer, just shines through one layer, and well, destroys your work. So you need to line this carefully, very carefully. As you know, usually I use magnifying glass just to check the registration on 2 layers, and when I'm satisfied I just glue it together with some marking tape, and I cut off the excess. And then again I check it on my board. If everything's okay, you're ready for applying UV solder resist. So you just apply it freely, and I put this cellophane. This is actually gift wrap paper. I use several things for this, but I find this gift wrap paper just because if you use like overhead transparencies or some other types of plastic, usually it sticks to this UV paint, and it's hard to get it off. Well, I was looking through my camera while I was doing this, so at the end it was not perfect. The layer was too thick, you will see at the end. You will need some experience for this, but generally thinner layer is better. You need to see the tracks through it. So I put the double tape just to fix my board to this piece of polyethylene that I'm using as a cutting board, and then I just put everything, I tape everything so it's not moving. I put a piece of acrylic glass over it, and my UV exposure device is busted. I need to make a new one, so I used the sun, and it didn't go. You need to do this at noon time, because well, I did it like 5 PM and it was not good. So I use acetone to wipe off any undeveloped solder resist paint, and you need to do this gently. You need to do this gently and apply a lot of acetone. You see my board is dirty now on the other side, so you have to use the acetone to clean it, and every time you do that you remove some of the silkscreen. Next thing you need to do is to drill your PCB. I'm using my drill stand here, my drill press, and well, this is tedious work. First I drill small holes, then I drill with a bigger, and sometimes I widen the hole like this if I need to file it after that. So I apply my template, the same one that I used for cutting the PCB. And then I sand off all of the edges to a correct size, and drill these bigger holes with a hand drill. This is I think I'm using 4mm drill over here, and when you finish you need to deburr every hole you did with this with the bigger drill bits. So corners on this case need to be like half or semicircle. So I use several files just to get it in place, just to get it on size, and I use pretty coarse files, so I just deburr everything at the end. And I use this key maker square file to make square holes that I need for some parts of the board. And well, more or less I'm completed with the board. Well, it's 15 minutes now, so I will split this video in several parts, and you can see the board fits perfectly into the casing. In the next video I will develop the rest of the circuit. Thank you for watching.